Hey, what's up? Welcome back. This is part 3 of this muzzle flash tutorial. I kind of feel like I'm running this thing to the grounds, but I don't care. Anyway, so since I did part 2, there were some updates to the high definition render pipeline, and some cool features were added to the visual effects graph that I thought we have to cover in this video. More specifically, we have LOD for mesh outputs. Now we can specify up to 4 meshes in the mesh output context, and we can use them either for mesh variants or LODs. And we're also going to take a look at how we can synchronize light and audio using output events. So previously I wrote this script which flickers this light and plays this audio with the same fire rate or fire delay as the muzzle flash, and it was not perfect, but using output events we can synchronize them perfectly, and I mean perfectly. If you don't know what output events are, they basically enables us to trigger a C# event from within the graph, and therefore enabling us to synchronize different events with the spawning of particles. They're extremely useful and they add so much flexibility to the workflow, as you will see, and we're going to use them to synchronize the audio and light to our muzzle flash without writing any extra script ourselves. But we can also trigger functions within our own scripts using output events as well, as I'll show you later in this video. Alright, so without further ado, let's get started. Alright, so first things first, let's add some LODs to these shell meshes. So here's our shell mesh, and it doesn't have LODs. There's only one mesh here, as you can see. Alright, so let's create some LODs for this mesh. Alright, so I'm using Blender, but feel free to use whatever software you like. Alright, let's import this mesh, and it has a terribly long name. Let's just rename it to 9mm LOD 0, and let's duplicate it and rename it to LOD 1. And right now it has 260 triangles. I'm gonna just get rid of all these faces here, and let's just fill this. Alright, that reduced more than 60 triangles. Let's add a decimate modifier, and let's set the ratio to like 0.8 and apply that. Alright, we're all the way down to 158 triangles. Alright, so let's duplicate that one more time, and let's rename it to LOD2, and let's again add a decimate modifier. Let's put it to like 0.8 again. I think it's enough, I don't know. Let's just export it as an FBX, and we're going to only export the mesh, and let's rename it to 9mm LOD. And there we have our mesh with different LODs. Alright, so I'm gonna open the graph. Let me dock it up here. Alright, so here's our shell system, and we have an lit mesh output, and as you can see we only have one mesh slot here, and if you select this output context in the inspector, you can see we have a mesh count, and if I increase it all the way up, you can see now we have 4 mesh slots here. And if we check this LOD, it's gonna automatically use these meshes as LODs. Alright, so as you can see, we have capsules here as the default mesh, and you can see that when the camera is further away, the shells turn into capsules. Alright, so I'm gonna change the distance where the LODs blend um, because we need more performance. So let's put this, and by the way, this XYZW, these are not XYZ, these are just the distances for these LODs stored in a vector 4. So don't get confused by the XYZ, these are just the LOD 1, 2, 3, 4. So let's just increase it to like 12 here, or 14, yeah. Let's put this to like 8, this one like 5. So I'm gonna duplicate this shell property and rename it to shell LOD, shell LOD1, shell LOD2, and let's duplicate it one more time, shell LOD3. We're going to plug these into this mesh 1, 2, and 3, and we're going to assign these as the mesh LOD1, mesh LOD2, and for mesh LOD3 we don't have any LODs, so we're just gonna give it none. And they're very tiny, they're not even visible, so let's set the size to like 2. Yeah, I think 2 is fine. Alright, so now let's synchronize the audio and light using output events. So in part 2 I did this script, which I already showed you. We're not going to use this, so I'm just going to remove it from this game object. And we're going to import the output event helpers. So let's go to package manager and find the visual effects graph, and from the samples import output event helpers, and it imports this folder which contains a bunch of scripts which you have to let it compile. Alright, so as you can see right now we don't have any audio or light. So I'm going to add this this one script, VFX output event play audio. So I'm gonna add this script to our game object, and it takes in audio source. So we already have an audio source, so I'm gonna plug it here, and as you can see we have an output event which has a name. So this script is looking for an output event with this name, and within our graph we can create output events. Alright, so here in our muzzle flash, from the spawn context I'm going to create an output event. Alright, so as you can see they have the same name, and the cool thing about it is it has this option to execute in editor, so you don't even have to enter play mode to test if they are working. Alright, so I'm gonna change this name to, and this has to have the same name in order for them to be synced. Alright, so that's the audio. Now let's see how we can add light to our muzzle flash. So we have this light object that I used to flicker on and off using this script that I wrote. And we have this prefab spawner script, which I'm going to attach to our game object. And we can spawn a game object with this. Alright, so I'm gonna make this light object into prefab, and we can delete it from here. And I'm gonna put it here, and let's instantiate 1. And let's change this output to the same output event we have in the graph. So now you might be wondering, where is the light? Why is it not spawning? So we're using these event attributes here, and we need to pass these from within the graph. So we have the lifetime and position, and the way to pass them is here in the spawn context, we're going to set spawn event position. So we give it the position, set spawn event lifetime 0.1 maybe. And here we have to check this parent instances so that our instances are a child of this game object. And we can adjust the lifetime to like 0.05. No. Alright, so if we're looking at this in slow motion, in like lower play rate, you can see that the light's lifetime is not the same as the muzzle flash. That will be fixed when you do the slow motion using by decreasing the time scale, because this is the visual effects play rate. It's different than the time. But if you're like me and you want to see the light in the slow motion here, you can fix that by multiplying this by, or dividing it by the VFX time, or like the rate, the play rate. So we have the play rate, and it goes from 0 to 1. It's clamped. And let's add a float here for our lifetime. And if you multiply these, you're gonna get an even smaller number, but if you divide them, you're gonna get this. So now, as you can see, the play rate is affecting the lifetime of our light prefab. And from here, it's just kind of fine-tuning this value. I think 0.06 maybe should do it. Alright, so here's the light and audio, but you can sync like everything you want with the spawning of your particles. For example, you can do cinemachine impulses. If you want to add some camera shake and synchronize it with your VFX graph. You have this Cinemachine camera shake too. And let's see how that works. Cinemachine camera. And we have this impulse source. So I'm not using Cinemachine cameras here. Alright, so let's create a virtual camera. Let's just call it cam. And here let's add an impulse listener. Impulse listener. Let's add it here. Impulse source. And let's drag it here and sync it to the same event. And we can use a recoil maybe, right? And here we should be passing a position and a velocity attribute. So we are already passing a position attribute. Let's add a velocity, set spawn event velocity, and we should give it some values. So let's give it like 0.05, 0.05, 0.05. And now you can see we have added some extreme camera shake using output events as well. Well, you probably should fine-tune these values, this velocity attribute, and you can do like literally everything. You can play animations, you can synchronize everything. Alright, so for example, I have this script. I wrote this script, and in here but one thing that I did in this script was to set the height for the collision plane of the shells, and I still want to do it, but now we can do it every time we shoot. So I'm going to put this this raycast, I'm going to put it in public void, and let's call it set collision plane height. And I'm going to do this inside here. Alright, so if I attach this script here again, and if we add the VFX output event Unity event, here we can add a list of events that we want to sync to this output event. So now I want to sync the set collision plane height with our fire event. Alright, so now as you can see, if I move this closer to the ground, you can see that they're still colliding with this floor. Pretty cool, huh? That it's perfectly synchronized. Alright, so that's it for this video, part 3 of this muzzle flash tutorial. Let me know if you want to see a part 4. Also, let me know if you want to see a more in-depth video about output events. And also, if you have any questions, let me know in the comments. I'll do my best to answer you. And if you like this video, give it a like and subscribe, so you don't yeah. Yeah, with all that said, peace out.